Okay, question 7, 2017 exam. A table of fatty acids and melting points is shown below, so just fatty acids. The question says, with reference to their structure and bonding, explain the difference in melting points between palmitic and stearic acids. So you need to look up your periodic table, data booklet I should say, to see that palmitic is this one and stearic is this one. So they're both, these ones are unsaturated, but these are both saturated. So if we draw this out, this particular one, we can see that we've got the carboxyl group on the end, and then you've got 15, where is it, that one, 15 carbons after that and 31 hydrogens. So 15 carbons, every carbon's got a hydrogen, so 15 times 2 is 30, plus the one on the end is 31. So you can see that they're all single bonded. Melting points means that you've got this fatty acid molecule and another fatty acid molecule. This should be the same length. I just drew it shorter. So these are both palmitic molecules. What's keeping them together so that they form a liquid are dispersion forces between the molecules. That's the main bonding between them. There would be dipole bonding here as well, but because it's only a little bit compared to the length of the molecule, the main intermolecular bond between molecules would be dispersion forces. So you can see that palmitic acid is shorter, has a shorter hydrocarbon chain than stearic. So because it's got a shorter chain, it'll have weaker dispersion forces. So it'll have a lower melting point. You need less energy to break the bonds. So when we're writing the answers, you need something about the structure of them, of both of them. So refer to the structure and bonding. So they're both saturated, which means they've got single bonds. You didn't need to write this. That's what saturated means. But palmitic, so I've given evidence that I've looked up palmitic. The evidence that palmitic is shorter than stearic, because I've written the formulas to show that this is a smaller number than that, so it's shorter. So the structure, they're both saturated, but this is shorter in structure. So it would have weaker dispersion forces between the molecules, and so have a lower, in my hurry I wrote boiling point, they would have a lower melting point. So I've highlighted where I've done the structure, the bonding, and the explain. So these are all structures. So we've got the structure of the two of them, and so it would have dispersion forces between the molecules, but if it's shorter, then they'll be weaker because there's less of them. So the explain part is the fact that these dispersion forces are weaker, and then that links it. So you have to kind of spell it all out. You can't just assume that they will understand this. So the weakest dispersion forces between molecules give it a lower melting point. Just check, like I did, because I was highlighting in green and then I realised actually they're talking about melting points, not boiling points. Just do a last minute check of your answer with the question and make sure you've totally answered the particular question before you leave it. So always do a last minute check. All right, the next one is between stearic and linoleic. Stearic and linoleic. So you can see the linoleic's a lot less. So there's something going on with it. So if you have a look, there's two that start with L, and there's actually two that start with P. When I first did this, I accidentally highlighted that one. So be really careful that there's the two that are different. So both of these, this one anyway, has got two double bonds in it. So if these are cis bonds where the two hydrogens are down, then those double bonds will cause a kink in the molecule. So the molecule will go up like this, hit the double bond, and then it will go down and kink. So when you're trying to get dispersion forces between molecules, if you've got a molecule that's kinked, you're only going to get bonds, dispersion forces between, that end, or if the whole kinked part is around that way, you'll get it on the short bit. But you'll have less dispersion forces between kinked molecules. So, stearic acid, you need to refer to the structure of the two, stearic and linoleic. Stearic acid molecules are saturated and have no carbon-carbon double bonds. So when you're referring to these double bonds, you can't just say no double bonds, because this O is a double bond. See that? CO is a double bond. So you can't just say they have no double bonds. You have to say carbon-carbon double bonds. So to get used to just referring to it like this. Whereas linoleic has two carbon-carbon double bonds and are unsaturated. So that's all your structure stuff. So then that means that if these double bonds are cis ones, the hydrogens are both down in the same direction, then it causes the molecules to kink. So it causes the whole chain to go like this, which prevents the molecules from packing together. So this is explained. I haven't highlighted in green. I need to highlight it in green. So what's the problem with kinking? It means the molecules can't pack together. And so the dispersion forces between them. So in the first time I said dispersion forces between. This time instead of saying between, I'm saying intermolecular bonds, which is the same thing as the molecule, the forces between. We can say the intermolecular bonds. So either you say the forces between or you say intermolecular, one or the other. So the bonds between them are weaker, and so the linoleic has a lower melting point. Okay. So when you read the examiner's report, you need to find the words which are key. The fact that you've got dispersion forces, but they're weaker because it's shorter. You need to find all the links and make sure that you put the links together. So each mark requires, 2 or 3 ideas that are connected and linked together. Okay, so 1 mark was awarded for the comparison of the size or length of the stearic acid and palmitic. So you had to compare the fact that one was shorter than the other. And then you have to relate the shortness. So link the idea that a shorter chain will have a weaker amount of dispersion forces, and so then result in a lower melting point. The same with the structures of linoleic and linoleic, the fact that linoleic has a double bond. And then explain about the kinking if it's cis, which forms less intermolecular. So a student's ability to coherently distinguish between the fatty acids in each pair in terms of both structure and bond varied. So when you have a look at the marks, you've got about 20% that are able to do each thing. So you really should be able to do all of it. Only 20% of students can get 4 marks for that question.